Oh, my fellow, in this case, science mortals, we're going to do a deep dive of Physics EM1, which is Physics, Electricity, and Magnetism 1. Basically, we're going to walk through it. So E&M Physics here, this is the main menu. On it, we have electrostatics, current, magnetism, EM waves, and circuits. So let's just walk through these. And it's pretty good because, it has everything labeled here. Coulomb's law, E field, Gauss's law, E potential, and back. So we're just going to walk through it all. So you see we have F equals K, Q1 times Q2, all divided by R squared, where F is electrostatic force, K is that constant 8.99 times 10 to the 9th Newton meter squared over C squared. Q1, Q2 are the charges, and R is the distance between the charges. First thing you see typically in electricity topic of physics. Okay, let's go to E field. So we have E equals F over Q, which is also KQ times R divided by R squared. So we've got, the little q and the big Q are the test and source charges. I like that they're separated like that and explained. And R is the distance from source, typical for physics stuff. We have like R squared or D squared in the denominator. So we're going to go on. We're going to go to Gauss's law. And it looks like we've got phi E equals Q over epsilon sub 0. And phi E is electric flux. Q is enclosed charge. And E sub 0 is a constant. Looks like it's 8.85 times 10 to the negative 12 F divided by M. So we continue, and then we're going to go E potential. And then got V equals K times Q over R, where V is electric potential. K is that constant. Q, big Q is that source charge, and R, again, distance from charge. So we're going to go back here. So we've done the first of 5 topics covered here. This is pretty awesome. If I had this in physics, oh my gosh, my life would have been so much easier to have all these formulas at my fingertips, and especially subdivided into topics. But that's cool. If you like it, like it. If there's something you want added or changed, hey, put it in the comments. I'm responsive to it. I'll get to it usually within 24 hours, but sometimes it takes a week. Okay, so let's go to current. We got Ohm's law, power, and current density. Let's go sequentially through this. V equals I times R, where V is voltage, I is current, R is resistance. Then we're going to go through power here. P equals I times V, which also equals I squared times R, which also equals V squared over R, which is cool because you've got now the 3 renditions of the power equation. And I is current, V is voltage, and R is resistance. That's pretty awesome because everybody's like, oh, all you have to do is memorize 1. Wrong, you have to memorize 3. Or you can get this program at mcstutoring.com, and save yourself the strain of memorization. Now we're going to go to current density. J equals I divided by A, where J is the current density, I is the current, and A is the cross-sectional area. So we're going to continue here, and then we're going to go back, and then go to magnetism. And then we've got B field for wire, B field for loop. So wire meaning it's pretty straight. The loop is like you're making a curved loop, typically of, I want to say a conductor of electricity. And then I got the Lorentz force. So let's go first for the B field for the wire. It's mu sub 0 times I, all divided by 2 pi r. And then so B is a magnetic field, mu sub 0 is that constant, 4 pi times 10 to the negative 7 t times m, all divided by A. And then I is the current, and R is the distance from the wire. So we're going to go on. And then we've got the B field for the loop. And then, man, this is a lot. It's mu sub 0 times I times R squared, divided by 2 times R squared plus Z squared, all raised to the 3/2 power. So B is a magnetic field on the axis. Mu sub 0 is 4 pi times 10 to the negative 7 t times m, all divided by A. I is current, R is the loop radius, and Z is the distance from loop center. So just keep that in mind. This is what hurts, is that distance from loop center, because we're not always assuming that is 0. Okay. And then let's go to Lorentz force. And we've got F equals Q times V times B. This is like an old school multiplication symbol, and it looks like a bug splatter or an enemy from Space Invaders. If you're very old, F is Lorentz force, Q is charge, V is velocity, and we've got B as a magnetic field. Then we're going to go on. We're going to go back now. We're going to go to electromagnetic waves. And then we've got the wave equation, energy density, and Poynting vector. So let's look at this. We've got the wave equation, c equals f times lambda. C is the speed of light, f is frequency, and lambda is wavelength. Just kind of interesting. When I was younger, I didn't know all this. So we're going to go to energy density now. And we've got U equals half times epsilon sub 0 times E squared plus B squared over mu of 0. And then U is energy density, not the mu. Epsilon sub 0 is 8.85 times 10 to the negative 12 F over M. E is electrical field, B is magnetic field, and mu sub 0, again a constant, is 4 pi times 10 to the negative 7th Tm over A. So we're going on the pointing vector. We have S equals 1 divided by mu sub 0 times E times B, where S is the pointing vector, mu sub 0, again, that constant, E is electrical field, and then B is magnetic field. And we're going to go back here, and then we're going to go to circuits. Now, this is interesting. Just you do want to study some schematics of the diagram you're looking at. For series versus parallel, series means in a row. Parallel, they're kind of like standing up next to each other. That's the best description I can give you. And then we've got the RC circuit. So let's go to series. So you have circuit and series. The equivalent resistance is the sum of all the other resistances. That's R1 plus R2 plus R3 plus ... where the R sub EQ, equivalent resistance, and R1, R2, R3, and it can go on to R4, R5. Just depends how many points of resistance you have. And those are the individual resistances. Now we continue, and then we've got the RC circuit. We've got Q of T equals CV times 1 minus E raised to that's what this little caret symbol means, negative T divided by RC. So we've got Q of T is charge at time T, C is capacitance, V is the applied voltage, R is the resistance, and T is the time. Cool, and that's it. So if you like it, I think that's everything. And then check it out, mcstutoring.com is where you can buy it. And we also have one for mechanics, which is actually a larger scale than this one, which is probably what most people encounter in a college, university, or AP first semester physics class. Okay, ciao for now, and good luck in all of your math endeavors. See you next time. Your source for TI84 calculator programs, mcstutoring.com.